Start with the topic that is exact differential equations. Already in 12th standard you have studied the differential equation. So now today we are going to start with what is the meaning of exact differential equation, and once the differential equation is exact, then how to find its solution. So the definition of exact differential equation is what? A differential equation, a d dot e dot means what? A differential equation. A differential equation of the form m dx plus n dy equal to 0. Now here m and n are any functions of x and y or constant. So a differential equation of the form m dx plus n dy equal to 0 is said to be an exact differential equation if and only if it satisfies one condition, and the condition is what? Partial derivative of m with respect to y must be equal to partial derivative of n with respect to x. Since we know that m and n are any functions of x and y or the constant, so if dou m by dou y is equal to dou n by dou x, and if the differential equation satisfies this condition, then only we can say that the given differential equation is an exact differential equation. If these two derivatives are not equal, then the differential equation will be not an exact differential equation. Okay. Now let us see some examples how to check whether the differential equation is an exact differential equation. So for example, I am taking this example. Say y square dx plus x square dy is equal to 0. What? Y square dx plus x square dy is equal to 0. Now whenever you want to check whether the given differential equation is exact or not, just compare the given differential equation with the differential equation m dx plus n dy equal to 0, so that we can identify the value of m and n. Now when you compare this with this differential equation, so m is what? M is a coefficient of dx, and n is what? N is a coefficient of dy. So after comparison, what here we have, m will be equal to what? Y square, and n will be equal to what? X square. So in our differential equation, m is what? Y square, n is equal to what? X square. Now in order to check whether this differential equation is exact or not, we have to calculate these two partial derivatives, and there we have to check whether these two derivatives are equal or not. Now find out partial derivative of m with respect to y. Now whenever you want to calculate partial derivative of m with respect to y, at that time we will treat x as a constant. So now here m contain only y square, so its derivative with respect to y will be what? 2y. Similarly, partial derivative of n with respect to x, it will be 2x. Now here what we have, dou m by dou y is 2y, dou n by dou x is 2x. So we know that these two derivatives are not equal, therefore the given differential equation is non-exact. Now therefore dou m by dou y is not equal to dou n by dou x. So what does that imply? Ki given differential equation is non-exact. So this way how we have to check whether the given differential equation is exact or not. We'll take another example also. Okay, so now let's take the another example. So example number 2 that I am going to take here is, say 2xy dx plus x square dy equal to 0. 2xy dx plus x square dy equal to 0, and the question is again same, ki check whether the given differential equation is exact or not. So now again we have to do the same thing that we did in the previous example. So in this example, first thing is what, ki we have to identify the values of m and n. What is m? M is always a coefficient of dx, n is always a coefficient of dy. So now here m will be equal to 2 times xy and n will be equal to x square. Now again find out the partial derivative of m with respect to y, similarly the partial derivative of n with respect to x. So now here partial derivative of m with respect to y. Since everyone know that whenever we are going to differentiate partially with respect to y, at that time we will treat x variable as a constant. So now here the m contain 2x into y. So now here only y is the variable, 2x is the constant, and since this 2x is multiplied with y, so while taking the derivative it will be as it is. And derivative of y with respect to y is what? 1. Similarly, dou n by dou x. So differentiate n with respect to x partially, and n contain only x square, so its derivative will be what? 2x. So here we can observe that dou m by dou y is 2x, which is equal to dou n by dou x. So the given differential equation is what? An exact differential equation. Now since dou m by dou y is equal to dou n by dou x, therefore differential equation is an exact differential equation. So now here we have seen the two examples where we have seen that how to check whether the given differential equation is an exact differential equation or not. Now in next we are going to study the solution of the differential equation. Once the differential equation is an exact, then how to find its solution. Then to find a solution we have a direct formula, and the formula is what? Ki integrate m with respect to x. Since we know that m and n are functions of x and y, means m and n can contain both variable x and y. So while taking or while finding the solution of exact differential equation, sometimes we have to keep some variable as a constant. So now first is what? We will integrate m with respect to x, but there we will treat y as a constant. There we will treat y as a constant. Plus we will take terms of n without x, and then we will integrate that terms with respect to y only. So here terms of n without x, and now integrate whatever the terms of n without x, integrate that terms with respect to y equal to the constant. Since it is a indefinite integration, so now here we have to add the constant of the integration. This is what the formula of solution. Now let us see some examples. Complete examples means check whether the given differential equation is an exact or not and find out its solution. Okay, so let's start with this example. Example 1, solve the given differential equation, and the differential equation is what? X plus y minus 1 times dx plus x minus y plus 4 times dy equal to 0. Now the question is like solve. Solve means what? There you have to check whether it is exact or not, and you have to find a solution also. So solve meaning is what? You have to solve the given example completely, means you have to find a solution. So now again the first step is what? Here we have to check whether the given differential equation is exact or not, जो कि हमने अभी अभी देखा है कि exact differential equation हम कैसे check करते हैं. So now here again compare the given differential equation with m dx plus n dy. Means what is m? M is what? The coefficient of dx, n is what? The coefficient of dy. So here m is equal to what? X plus y minus 1, and n is equal to what? X minus y plus 4. Now here we have to calculate partial derivative of m with respect to y and partial derivative of n with respect to x. So now we have partial derivative of m with respect to y. Now since we have just seen that whenever we are going to differentiate with respect to y partially, at that time the x variable we will treat as a constant. So here first term is what? X, which is constant with respect to y. So its derivative with respect to y will be 0. Derivative of y with respect to y will be 1. Derivative of 1 with respect to y will be 0 because it's a constant. So dou m by dou y is equal to what? 1. Similarly, dou n by dou x. Now while integrating with respect to x, we will treat the y variable as a constant. So now here the first term is what? X. So derivative of x with respect to x will be 1. Second is y. Derivative of y with respect to x is a 0. Why? Because y is a constant with respect to x. So it's 0. And derivative of 4 with respect to x is again 0. So now here what we have? Dou m by dou y equal to 1. Similarly, dou n by dou x is also equal to 1. So the given differential equation is what? An exact differential equation. So what does that imply? Partial derivative of m with respect to y is equal to partial derivative of n with respect to x. And what does that imply? The given differential equation is an exact differential equation. Okay, now once we done with the first step, that is the checking of the differential equation whether it is exact or not, the second step is what? We have to find its solution. So solution is solution. So first we'll write down the formula of the solution, and the formula is what? Integrate m with respect to x, keeping y constant, plus take terms of n without x, and then integrate that terms with respect to y equal to will be constant. Okay, so in first integration we have to write whole m as it is, but just while doing the integration we'll treat y as a constant, only we'll treat x as a variable. Now in second integration we have to just choose those terms of n which do not contain x, and we have to integrate that terms with respect to y. So here what is our m? M is equal to what? Here x plus y minus 1, and we'll integrate this total term with respect to x by treating y as a constant. Now in second integration we have to take only those terms of n which do not contain x. So now n is equal to this, what? X minus y plus 4. Now in this n we will not take x, we will just take minus y and plus 4. So it is what? Then integration minus y plus 4, and integrate this with respect to y equal to constant. Now integrate term by term. So now everyone know that the integration of x is what? X square divided by 2. See, while doing integration, we have to just increase the power by 1 and write the same power in the denominator. So now here originally the power of x is what? 1. Just add 1 into that, so it will be x square. Write down the same power in the denominator. Plus, now the now the next term is what? Y. But since we know that y we are keeping as a constant, and since we know this formula, what formula of the integration? Integration of the constant is what? That constant into whatever the variable is there, that variable we are multiplying here as constant of the integration c. Now next term is what? Y. So with respect to x, since we are keeping y as a constant, so here y will play a role of k. So the integration of y using this formula will be y times x. Since here we are giving the constant of the integration, but the total constant of the integration we are already adding on the RHS. So no need to add c1, c2, c3 here. Okay. Now yx, and again now here 1 is what? Again the constant. So 1 is what? Again a constant. So its integration will be minus x plus. Now here in second integration, there we have to integrate with respect to y variable. So the first term is what? Y. So integration of y with respect to y will be y square by 2. Okay, and the minus sign will be as it is. So it is minus y square by 2. Again here 4 is a constant. So using the same formula, this integration of 4 will be 4y equal to constant of the integration, that is c. This is what the solution. Okay, so this way how we are finding the solution of exact differential equation. So let's start with the second example. Now the second example is given on the board, that is solve the given differential equation. So the differential equation is what? Sin x into cos y plus e raised to 2x into dx plus cos x into sin y plus tan y into dy equal to 0. So again this differential equation will solve by the exact method. So first we will check whether it is exact, and then we'll find the solution that we did in the previous example. Okay, so I request everyone to pause the video and try this example on your own, and then come back and see the video. So m is equal to what? Sin x into cos y plus e raised to 2x, and n is equal to cos x into sin y plus tan y. Now we'll find out partial derivative of m with respect to y. Now again, whenever you want to calculate partial derivative of m with respect to y, as I told you earlier, there we will treat a x term as a constant. So in first term, sin x into cos y, but since we are differentiating with respect to y, so sin x will be a constant, so that will be as it is because it is in the multiplication, and derivative of cos y is what? Derivative of cos y is minus sin y. Plus now e raised to 2x. E raised to 2x is what? A constant with respect to y, and which is in the addition. So the derivative of the constant will be 0 here. Similarly, partial derivative of n with respect to x. Now whenever we want to differentiate with respect to x, there we will treat y term as a constant. So now here in first term cos x into sin y. So sin y is what? A constant, and that is in the multiplication. So that will be, or that will remain as it is while doing the derivative. And derivative of cos x is what? Minus sin x. So it is minus times sin x into sin y, and tan y is what? Total constant term with respect to x, and since it is in the addition, constant term in the addition, so its derivative will be 0. So now here we can see that dou m by dou y is equal to dou n by dou x. So the given differential equation is what? An exact differential equation. Now since dou m by dou y equal to dou n by dou x, therefore given differential equation is an exact differential equation. Okay. Now the next we are going to find a solution of this differential equation using the same formula, and the formula is solution integrate m with respect to x treating y as a constant plus take terms of n without x and integrate that terms with respect to y equal to constant. Okay, so now we are here in first integration we will write m as it is, and in second integration we have to choose the terms of n without x so that we can do their integration. Okay, so now here we'll write m as it is, and the m is what? Sin x into cos y plus e raised to 2x. These terms we have to integrate with respect to x by treating y as a constant. And now here we have to choose terms of n without x. So now n is this, what? Cos x into sin y plus tan y. So the first term, that is cos x into sin y, contain a x term. So we will exclude that term, or we will not take that term while doing the integration. So from n, only the second term will come under the integration, that is tan y. Integration of tan y with respect to y equal to c. Now, while doing the integration here, we have to revise some formulas of the integration that we'll write here aside. So, the first formula that we are going to use here is integration of sin x. Integration of sin x. So, what is integration of sin x? It is minus cos x. Second formula that we are going to use here is integration of tan x. What is integration of tan x? That is log of sec x. The third formula that we are going to use here is integration of e raised to ax dx, where a is a constant, and the formula is what? E raised to ax divided by derivative of the power with respect to x. Now the derivative of the power is what? A. Now we'll divide by a. So these are the three important formulas that we are going to use here while solving the integration. Let us revise these three formulae again. So the first formula is what? Integration of sin is what? Minus cos x. Integration of tan x, that is log of sec x. Integration of e raised to ax is what? E raised to ax by a. Now just take term by term integrations. So the first term is what? Sin x into cos y. But since in this term we'll treat y as a constant. If y is a constant, then cos y will be a constant, and cos y is constant, but that is in the multiplication. So while doing the integration, that will be as it is. So cos y will write as it is. Sorry, cos y will write as it is, and the integration of sin x using this formula. What is integration of sin x? Is minus cos x plus. Now the second term is what? E raised to 2x. So the integration of e raised to 2x using this formula. So when you compare this term with this formula, so the value of a is what? 2. So using this formula, the integration will be what? E raised to 2x divided by 2. Okay. Now the second integration is what? The integration of tan y. So using this formula, it's just variables are changed there. Instead of x, there is a y, but the answer or the formula will be the same. So integration of tan y using this formula will be log of sec y equal to c. This is what then the solution of the given differential equation. You can more simplify this by removing this bracket or multiplying throughout by 2, and then change the constant of 2c by 2c by c1. These things also you can do, or you can keep your answer like this only. So with this example, we will end our video here. If you find this video helpful to you, then please like it, subscribe my channel, and share the video with your friends. Thank you.